Hello, my name is Jimmy Vegas, and welcome to this, the third in a series of video tutorials on how to create an Android and iOS mobile game in Unity 5. So this episode, we're going to write a script which will enable us to fly our rocket here. So with it being an endless runner, we want it to continually move, and then when we press the spacebar, we want it to move up the screen. So first and foremost, what we need to do is if you head to your rocket just there, go to Add Component, and you can go to Physics and Character Controller. So this is vital to the script we're going to use because we need to reference this particular component to actually get it to work. What we'll also need to do is go to Edit, go to Project Settings, and go to Input. What you need to do then is, presumably yours will probably look a bit like that. It's got nothing here, just access at the top, click the arrow, and then head down to here where it's got Jump. Click on it. The name should be Jump. You may have a positive button as joystick button 3. I'm not entirely sure, but your Alt positive button just there, type in space bar. Head back here and just save that just to be safe. So we need to write our script now. Hopefully this episode won't drag on for too long. The script isn't complex, but everything in it may seem a little daunting, especially if you are brand new to Unity. I will try to explain my best as we go along. So firstly, we need a folder where we can store all of our scripts. So if you go over here where it says Assets, right click, Create, Folder, and type in Scripts. Head into that folder, right click again, go to Create, and go to JavaScript. And I'm going to call this one nice and simple, Controls. So if you hit enter on that script there or double click, it will open up in either MonoDevelop or Visual Studio. By default, I'll be using MonoDevelop. I think a lot of Unity game engines these days will probably open it up in Visual Studio. It makes no difference which one you use. The script will still be exactly the same and it still work the exact same way. If you want to use MonoDevelop and you only seem to open Visual Studio, if you head into Unity, go to Edit and go to Preferences, just here. In External Tools, you can change it just here. So if you're using Visual Studio and you want to use MonoDevelop, you can change it there. Vice versa, if you're using MonoDevelop and you wish to use Visual Studio, you change it in the exact same place. So heading back to our script, it's already written a few lines of code, but we don't want them. We're going to start afresh. So let's delete them completely. So for this script, we need to set 4 variables. Now, a variable is something that we can set early on in the script to define something. In this case, for example, we can define our speed, which we can then reference later on in the script. So the 4 things we'll need are the speed of our rocket, the jump speed, i.e. how high it can go when we press the spacebar, our gravity, and we also need a variable which will give us our position using vector 3. Now, the best way and easy way to describe vector 3 is to give a position within a 3D environment. Now, although this game is technically 2D, it's realistically 2.5D, which means there are 3D elements to it, even though we're only playing in 2 dimensions. So to get things started, type var, which is short for variable. It's how we define every single variable within a script. Speed, and remember, when we type scripts, things are case sensitive. So if you put a lowercase s there on speed, you need to put a lowercase s on speed every single time. And then colon, and that needs to be of type float. Now a float is a number, but more specifically, a decimal number. An integer would be a whole number, so if you wanted to use integer, you would type int instead of float. Let's make that equal to 8.0, and then end the line with a semicolon. Most lines will end with a semicolon within this script. It's just the way it knows that that line is complete and it can move on to the next line. So the next variable will be jump speed, and again that will be a float. Let's make that equal to 9.5, just as a random number that we'll pluck out the air, and we'll see what we get to with it. The next variable will be our gravity, and that again will be a float. And let's make that equal to, that's going to have to be quite high-ish, so let's have 40.0, and then semicolon. The final variable, as I said, let's call this move direction. Now I have put a lowercase m on move and an uppercase D on direction. And that has to be the vector 3 that I spoke about earlier. So vector 3, oops, in fact, sorry, that is a colon there because we have to define the type, which is vector 3. And then it's equal to vector 3 dot 0. So we're zeroing out this particular variable, and then semicolon. So after the variables, we need to define something which is in every single script. It's a function. A function is something which can be called to execute within the script. And the function we're going to use here, it's a lowercase f on function, an uppercase U on update. An update function, or function update, whatever you want to call it, is something which is called every frame within the game. So in other words, it's running constantly. So you need open close bracket and then open curly bracket. Now within this, we need to set another variable, which is our character controller, which we added to our rocket earlier on, just there. So var, let's call this controller, and we'll make it character controller, and we need to get the component, so we make it equal to get component dot open spiky bracket, and then character controller, close spiky bracket just there, and open close bracket and semicolon. So all we've done for this line just here is we have said that our variable called controller is equal to the component called character controller that we added earlier on. So the next thing we need to do is we need to check if our controller is grounded. Now, it doesn't necessarily mean that it's attached to the ground that you and I walk on. More of an object that we can set is an object that it will land on. So we need if, and then controller dot is grounded. That's a lowercase I and a capital G on grounded, and then close bracket, and then open curly bracket. We need to perform this script if we are on the ground. So the next couple of lines is what we'll do. So we need to move direction equals vector 3, which, as I said, is kind of like the 3D environment. We need 0, comma 0, comma input dot get axis open bracket double quote, and we'll put horizontal. Now we'll see how this pans out later on. We may need to change that to vertical. I'm not quite sure. We'll see how this works when we attach the script to our object. So all that's basically doing is it's receiving some details about us. So we'll also put plus probably 3 at the end, and then we'll see how that works. Close bracket, semicolon. Next one, we need to do move direction again, and we need to make that equal to transform dot transform, oops, spell that wrong, form direction, and then open bracket move direction, and then semicolon. Best way I can describe this line is we are just moving our character controller in the correct direction that it needs to move. If you're having problems with the script, and I've no doubt some of you will because it is fairly complicated for this stage, you can get it on our website. If you look in the description for the video, you can find a link to our website. Head over there to the downloads and assets section and you can just download this script and use it straight away. The next one we need to do is multiply our direction by the speed. So in this case, we've set it to 8. So we need move direction and then star, which is multiply, equals speed. So remember, if you put a lowercase s on speed before, put a lowercase s on speed right here. Then we need to perform another if statement. We need to check if we're pressing the jump button to move up the screen. So if, open bracket, input, and that is a capital I, dot get button down, and then open bracket, and we need to define which button we're checking for. So in the quote marks, jump, which is what it's called, and then close bracket, and then open curly bracket. This is what we need to do if we are pressing down this button. We need to move direction dot y, so we're moving direction on the y-axis, which is up and down. We need to plus equals the jump speed, semicolon, next line down, and close curly bracket. So once again, it's checking if we're pressing our jump button. If we're moving ourselves upwards. Excuse me. So after that, we need to close our original if statement with another close curly bracket. We also need an else statement. So if you type else and then open bracket, so we're using logic gates here now. So if something is happening, do this, otherwise do this. So after else, we just need to check if we're pressing the jump button. So if you copy those 3 lines there, the if all the way to the first close curly bracket, and paste them after the else open curly bracket, it performs this. So it's always performing the check if we're doing the jump button or not. And then close curly bracket. So the next thing we need to do is to apply the gravity. So we need to always ensure that gravity is working for us. So if we go down a couple of lines and we put move direction dot y minus equals, and then gravity star, which is multiply, time dot delta time, and then for sanity's sake, just to make sure it does work correctly, we'll multiply that by 2. So realistically, what this means is that we're bringing our rocket ship down in time with the game. So once we've done that, we need to ensure that we're moving our controller in the correct time with the game at all times. So move direction dot move, remember that's a capital M on move just there, and then open bracket, and then move direction again, multiply that by time dot delta time, close bracket, and then semicolon, and then close curly bracket, and that closes our function. So if we save that by holding Control, pressing S, or going to File and Save up top, hopefully when we go back into Unity, we shouldn't get, okay, move is not a member. Okay, so if we go to console, we've got an error saying move is not a member, blah, blah, blah. If we double click that just there, it should hopefully take us to the line where we have a problem. So let's see, it doesn't like this. So why does it not like it? Let's check our variable. So var move direction vector 3 equals vector 3 dot 0. Okay, so why does it not like this just here? Oh, it's not move direction, is it? Nope, it's the controller. So right there on that last line, it should be controller.move, not move direction.move. That would be pretty silly if we were trying to actually do that, because we want to move the controller, not the direction itself. So change that to controller, press save, head back to Unity, and this should disappear. And it does. So we have a couple of other errors there, but we'll clear them. They don't matter too much. So next thing we need to do is our rocket itself. We need to rotate, I think, the actual rocket. If you rotate by 90 degrees just there, and then click on rocket base itself, and then rotate minus 90, just to get it facing the right way again. We need to change the scale a little bit as well, it would seem. Nope, wrong way. Sorry. So if we change the X to, no, let's try the Y. There we go. Okay. So if you rotate and it goes a little bit squishy, you can just change the scale there to get it back to how it was. So the rocket itself, if you remember, has the character controller on. We just need to drag and drop our control script onto the rocket. Scroll down, you'll see you have the speed, jump speed, gravity, and the move direction that we set as our variables. And the final thing we need to do is we need to go to Game Object, 3D Object, and Cube. We need to set the ground that we need to work with. So if you have your cube, move it outwards, downwards somewhere, and we need to expand it so as it's below our rocket. So let's change the scale on the X to 50, just to be safe, so it's nice and big. Change the scale on the Z or Z to, let's say, 20, just to be safe again. Click on your camera, and in fact, we'll just pull it out a little bit, so we should be able to see our rocket. So if we press play now, our rocket should fall to the ground and then move along with any luck. So we press play, and off it goes. So now let's see if our height works. So if we press play, let it hit the ground, and then press space, it does start working, but we need to modify our figures just here. So let's have our jump speed as 20, save. In fact, put 20.5, I think, and then save. Head back to Unity. Just thinking about the script. Still thinking. Okay, so let's press play. Try again. Okay, I think it may be our gravity. So let's reduce our gravity to 20 and save again. And let Unity have a quick think. And then press play. And it is working. Our rocket is kind of going up and down. There might be a better way of actually getting it to work correctly. Let's take off the gravity, this multiplied by 2. Let's take that off and save and try again. There we go. So our rocket now flies a bit more accurately. So we'll leave that tutorial there for now. The next one, what we'll have to do is put a camera, or rather attach our main camera to our rocket, but allow it so as it just follows on the x-axis, not the y-axis. Because if we were to attach our camera to our rocket now and press play, our camera would move exactly in time with our rocket, which I don't really want it to do. I want the rocket to go up and down the screen like it would on a normal endless runner. So I'm just going to uncouple that there, and I'm going to save that. So until the next episode, you play around with your script just here, and you get it, play around the numbers, and you get it up in the gravity and the speed exactly how you want it. So until next time, thank you very much for watching.